The last topic I would like to cover in this series, let's say, about contactors, changeover contactors, the three-phase contactors, and how we connect them. We spoke about how we connect it to the three-phase motor, which I think its name is the 3D synchronous motor. Now I want to talk about connecting the three-phase induction motor. Problem is, I don't have a three-phase induction motor and I do not have three contactors. So we're only going to draw the circuit and we are going to talk about it. The model of a three-phase motor, you have the rotor and the stator body. This is where you would access the coil and make all the connections you want. And that's basically it. So let's talk about this. Normally, what you will have is the motor is going to be over here, and then we are going to have 6 sets of wires like this, and we're going to have the mains power. This is going to be phase 1, phase 2, phase 3. And here we're going to have the control 1, control 2, control 3 if you want. I just want to make sure that the camera is all good. So first thing, we are going to get a contactor and we are going to put it over here in line with the live wires over there. This will actually provide the power to the motor. But now I need to see how I can turn on this motor. Instead of having a capacitor to turn it on, we use the star and the delta. Star and delta configuration. The way that I connect the star and delta is how I connect the coils inside via the wires through the contactors. Let's see how we do it. For the star, I'm going to have, I have to do this as a coil, it's not a resistor. There's going to be a coil over here, and then we're going to have another coil over here, and a third coil over here. This one will be C1, this one will be C2, and this one will be C3. And for the delta, I'm going to have the inductor like this, like this, like this. And this is going to be C1, C2, C3. I need to apply this setup, this connection between these nodes via contactors. So the first thing, let us take care of the star. What we can notice in the star, let us draw the contactor diagram. The first thing we're going to notice in the star that all the coils are connected to one common point in the center. So if I have over here C1, C2, C3, how would these get connected if they are all going to a single point in the center here, which is, let us call G, arbitrary. I can make a loop over here on the top. So this will be my star connector, and the wires are gonna come out of here. We'll talk about how we're gonna connect them later. Now let's talk about the delta. C1 is connected inductor, C2, C3, they are connected in series. So I'm gonna have another contactor, three-phase contactor right over here, and I'm gonna have C1, C2, C3. So C1 is going to go over here, C2 is going to go over here, C3 is going to go over here. And this one is going to take from the main, this top part. We'll take from A1, C2 will take from A2, from phase 2, and C3 will take from phase 3. It's going to look something like this. And what is going to go to the connection over here? I'm going to take C3 from here, C2 from here, and C1 from here. Tuck, tuck, tuck. Let us call this contactor, this is the delta first, and this is the main contactor. So we have three contactors. One is in a star configuration, another one is in the delta configuration, and the third one is for the mains power supply. So first of all, in the first part, we are going to have the main and the star, it's going to be closed. This is because all the current is going to go to a common point to start pushing the motor to turn. So that's the contactor closed. Second part, after a timer runs for a certain period of time, it will switch to another configuration. We are going to have main, which is here, and we are going to have delta equals star, and these are going to be open circuit. So the motor will run as a generator. This one is closed. These two are open to run as a generator. 3, we can have the main and delta closed, and the motor is connected to full load. That's how it will work. A quick sum up. We have coils inside the motor over here that are connected to one another in a certain way. And they give us 3 wires as an output, C1, C2, C3. We are changing the configuration of the coils inside the contactor via these 3 wires and how they are connected via the contactors. One contactor is configured as a star so that all the current is focused in one place and we can start pushing the rotor. We have a delta, which it will after a certain time switch to the delta, which will turn it into this, and we can have rotation. And we are supplying it with power, but changing the configuration of the coils to start pushing it. Obviously, we are going to have different protection mechanisms. So before we come here, we are going to have fuses or a phase fail protection in case one of the phases has failed or is not making a proper connection. That's how it is going to work. This is how we would connect these induction motors through the contactors and make it run. Actually, no. These two phases are actually switched when we connect it to the motor. This one and this one, these two are switched over. This is all correct, but when we connect it to the motor, this one is going to connect to C2. The middle one is going to connect to the first one, and the third one is going to connect to the last one. That is how the connection is done right. Now, let us talk about the safety of contactors. Since we have more than one contactor, so 1 plus contactor, let me get a new page. Let's stick to this diagram. So, since I have more than one contactor, 1 plus contactor, I need to have something to make them safe. I cannot have them turning on together. It will create a short circuit. It will damage the motor. So I need to have something. This is one contactor, and this is something. This is another contactor. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. This one's connected over here. Okay. This one's connected over here. Okay. This one's connected over here. These two are shorted. This one's going, and I have wires coming out from here. But what guarantees that these two will not turn on at the same time? We need some sort of protection for it, a protection mechanism. We call these things interlocks. Inter because they come between them and they lock them. One cannot turn on without the other. If we go back to the three-phase motor that we wired, if we go back to this three-phase contactor, we can see that over here there's a gap, and over here there's also a gap. When you move the sticker out of the way, normally they are covered, and the sticker would say for interlock use. You can see when I push the button over here that this one will move back, it will block it. And this one will also move back, it will block it. This is because there is normally a pin inside. So when we press it, that pin will go into the other side of the other contactor. So that pin will go in like this, stick inside, and it will not let the contactor activate. This is what we call a mechanical interlock. A mechanical interlock. It will sit between them, and one pin will be over here. When this one is on, button activated, the coil is energized, the pin will go into the opposite one so that that one does not get energized, so that that one's button does not push in, it cannot get activated. This is the first level of safety that we have. It just sits clips between them and we put it on the DIN rail. The other one is an electrical. An electrical interlock. Now we're gonna go step by step. I have one contactor and I have another contactor. What's going to happen is that I have my lines that are coming in over here. There's going to be a switch on them, a mechanical electromagnetic switch. And I'm going to have a coil by them. What's going to happen? Sorry, these are normally closed. These are going to be normally closed. What's going to happen? This one is connected to here, and this one is connected to the opposite one. And they are going to receive, these coils will receive power as normal. When this one is activated, A and B, when we have A is on, it will send power to this one. It will open this. It will open this switch. Switches are open when A is on, so that this one does not receive power at all. And if the same case is for this, if this one is off, this one is on. They switch. So that's the electrical interlock. I have my contactor got excited over here. It's conducting electricity. It will conduct electricity to this coil that will open the switches over here so that this contactor does not receive power. And just something just to clarify, it's not the three-phase lines that are going to be open circuited. It is the main lines that are going to be connected through A1 and A2. The lines that we connect through here, these are the ones that are going to be connected to this electromagnetic switch that is excited by the opposite relay, the opposite contactor. If this one is on, the switch is excited and it is left open circuit. If B is off, there's no power over here. These are closed circuit and the electricity can come here. If A is off, electricity can come here. What is the recommendation? Is to have both a mechanical and an electrical interlock. Whenever we are using two contactors, they would sit side by side here. And that is I think we can say that is the end to the series of the contactors. We explained the operating principle, how they have an electromagnet inside of them. Then we saw the changeover contactor, and we hooked up a motor. We hooked up a three-phase induction motor and a synchronous motor, and we checked out how we switch between star and delta. And we finished off with how we interlock them together so that if we want to apply the circuit, to remember that we need to have a mechanical and an electrical interlock especially between the star and the delta configuration.